Module 8, Parametric Equations. In the first lesson in Module 8, Lesson 25, Sketching Curves Described by Parametric Equations. We have here that Module 6 introduced us to polar coordinates and curves, which allowed us to draw curves and figures that would not be considered functions in the Cartesian coordinate plane. But polar coordinates alone will not help us graph the more complicated shapes like those shown to the right here. In these cases, we will turn to parametrizing curves by creating a system of equations to represent each variable individually. You can think of parametrization as mapping the path a person takes in a forest path or a particle moving through a two-dimensional space. Importantly, we will need to include what we have as the orientation of the curve using arrows, which represents the motion along the curve. And that's all that we're really thinking of. With this image on the right side here, think first about what is happening just to the x-coordinate, because otherwise this is not going to be a function. It's going to fail the vertical line test quite a few times. But if I just think about, say, what's happening to x, from my starting point here, x as I progress along, x is just getting smaller and smaller. Just looking at x is getting smaller and smaller and smaller until I get to about here. At this point, x is going to be the smallest that it can be in this curve. And as I continue along this curve, x now starts to get larger and larger and larger and larger, and continuously so. When I define a function where I have something that is getting progressively smaller and then it starts to get larger, that sounds like a parabola. So maybe I can define x with a function that's similar to a parabola. Y, on the other hand, if I again trace this and think about y, as I trace along this curve, y is now getting larger and larger and larger and larger and larger up until I get to here. After that point, y starts getting smaller and smaller and smaller until I get here. Then y starts to get larger again. Well, I started low, I started to get larger, and then I decrease and then start to increase again. That sounds like either a higher exponent of x, perhaps x to the fourth power or something, or a variable to the fourth power, or maybe even kind of like a sine or a cosine wave, which naturally increases and decreases over time. So perhaps I could define what is happening to x and what is happening to y independently using functions that, well, are actually functions in the Cartesian plane. We will typically do that by defining each of them as functions. So we'll define x as a function of the variable we often use as t, and we'll define y as a function of t as well. The reason t is most conventionally used in this case is because, from the context described here, we very often think about this as, where are you over time? At what point do you start in this curve, which would be at time 0, and then after so amount of time, where are you now in the curve? Just like if you were to be walking along the path in a forest, where are you at the beginning of your path? Where are you 5 minutes in? Where are you 10 minutes in? And so on and so forth. We tend to use t because we think about it very similar to a time variable. But that's what we're going to see in lesson 25. Rearranging x and y in terms of functions of t instead, and trying to graph the parametric function of x and y in terms of t to create a Cartesian curve.